Hello everyone, welcome back again in Arrays in C part 2. In last video you have learned one dimension array. In this video you will learn multi-dimension arrays. Our topics covered in this video are what do you mean by two-dimension array, multi-dimension array, then how to declare two-dimension and multi-dimension array, how to initialize two-dimension and multi-dimension array, memory representation of 2D array, how to access the 2D array elements, then how to find size of 2D array and finding the address of any 2D array elements, an example of C programs based on two-dimension arrays, and assignment on about topics. Two-dimension array. Two-dimension array is a fixed length array in which we store similar type of data in row and column format, or you can say tabular format. So two-dimensional array is also referred as matrix or a table. Now two-dimensional array has two subscripts. One denotes the row and another denotes the column. So in other words, we can say two-dimensional array is an array of one-dimensional arrays. You can see in this figure two-dimensional array having 3 rows and 5 columns. So you can see here we can store data in tabular format. Subscript starts from 0, row subscript and column subscript starts from 0. Now next is multi-dimension array in C. Two-dimension also is a part of multi-dimension array. An array having more than one dimension is called as multi-dimension array. Now by placing the n number of brackets, we can declare the n-dimension array, where n is the dimension number. In general, we can declare an n-dimension array or multi-dimension array as follows. First specify the data type, then array name, and then specify the dimension. So D1, D2, D3 are dimension. In this figure, three-dimension array is shown, where here three tables are there. Means in 3 dimension, first dimension indicates number of tables, then second dimension indicates how many rows, and third dimension indicates how many columns. So here you can see first dimension indicates sets of rows and columns. So here are 3 sets of rows and column. Then how many rows? There are 3 rows. How many columns? There are 3 columns. So this is 3 by 3 by 3 3-dimension array, which indicates the 3 sets of 2-dimension arrays. Now how to declare 2-dimension array? An array consisting 2 subscripts is known as 2-dimension array. In 2-dimension array, data is organized into row and column format, as a tabular format. In syntax, first declare data type, in array name, then in square brackets specify the row size and column size. Now type can be anything, int, float, character, like that. Array name, it should be valid identifier name. Row size, first dimension indicates row size, so number of rows in a 2D array, and column is number of column in a 2D array. Now rows subscript and column subscript always start from 0. For example, int matrix 3 by 4 means it matrix having 3 rows and 4 columns. So where your first index shows the number of rows and second index shows the number of columns in the array. You can see in this figure 3 rows are there and 4 columns are there. So rows start from 0 and columns start from 0s. Row subscript start from 0 and column subscript start from 0. You can see here in a memory. See, memory is a linear or sequential. In memory we cannot store it in tabular format. It is stored in a sequential format, row by row, or you can store it in column by column. So you can see here data is stored in memory sequentially, a linear format, row by row. So next topic, how to initialize the 2-dimension array. For example, suppose int a having 2 rows and 3 columns can be initialized like this. In curly braces, specify all the 6 values there are 2 rows and 3 columns. So 2 into 3, 6 values. So 0, 0, 0, 1, 1, 1. This value initialized as these values are initialized as row by row. So first 3 zeros are the first row, and second row contains the 1, 1, 1. So it initializes row by row. Now same statement can be written as int a 2 by 3 equal to, in curly braces, again you specify curly brace for row which contains all zeros, and second row again in curly braces which contain all the ones. You can also initialize the two-dimension array in the form of matrix as shown below. Here you can see here int a 2 by 3 equal to, in matrix format, opening and curly braces, in that again 0, 0, 0 and 1, 1, 1. In tabular format here you can see. When the array is completely initialized with all values, then there is no need to specify the first dimension size. You can avoid the first dimension size here. Like this int a, I have not mentioned the size here, and 3. And in the array, an array is initialized with the 2 rows and 3 columns. So 0, 2, 3 and 2, 1, 2 are initialized values. So 2 rows are there and 3 columns are there. But if the values are missing while initializing the array, then missing values are automatically set to 0 by compiler. So here int a of 2, 2 by 3, and here first row only initialized with the 1, 1, and second row initialized with the 2. So missing values are stored automatically by 0 to 0 by compiler. We can also initialize two-dimension array at a runtime using for loop or while loop. For example, here for I equal to 0, I less than 3i plus plus, and for j equal to 0, j less than 3j plus plus. In that loop you can see scanf %d and %array of I j. So first I controls the number of rows, and outer loop controls the number of rows, and inner loop, that is j, controls the number of columns. So here 3 by 3 array is initialized at a runtime. Our next topic, 3-dimension array declaration. A 3-dimension array or 3D array in a C is a collection of 2-dimension arrays. It can be visualized as multiple 2D arrays stacked on top of each other. A syntax: first specify the type, an array name, and then 3 dimension here. So first dimension indicates how many number of sets or 2D arrays are there. Then second dimension indicates number of rows in 2D array, and third, number of columns in a 2D array. So type can be anything, int, float, char, like that. Array name should be valid identifier. And first dimension indicates number of 2D arrays, y indicates number of rows, and z indicates number of columns. So for example, int array, three sets having 3 rows and 3 columns. This array contains 3 tables, you can say. In that table having 3 rows and 3 columns. Now how to initialize the 3-dimension array? As similar to dimension array, we can also initialize the 3-dimension array like this. Here int test having 2 sets or 2 tables, and each table having 3 rows and 4 columns. So in curly braces, here 2 sets. Again in that set, again here curly braces. In that curly braces, the 3 rows. So 3 rows here, and each rows contains 4 columns. So 3, 4, 2, 3, 0, minus 3, 9, 1, 23, 12, 23, 2 are the 3 rows, and each row contains the 4 columns. This is the first set. That comma. Now in second set, again same thing. Again here 3 rows and 4 columns. After that, close the closing braces here. Also, we can initialize three-dimension array like the matrix format. So you can see here int array 3 by 3 by 3. So here there are three sets or three tables. You can see here first, second, and third, and each table having three rows and three columns. So you can initialize in tabular format or matrix format like this. Now we can visualize the like this three-dimension array here. There are three sets here, and each set contains columns and rows. So here 3 by 3 array having three tables and having three rows. Here you can see three rows and then three columns. But in the memory it is stored as a linear format. So it is stored as a first table, in first set, then second set, and third set like this. Next topic, how to access two-dimensional array elements. In one dimension, we access the one-dimensional array elements using subscript. In the similar manner, two-dimensional array also accessed by using the subscript. But here we require two subscript. First, the row index or row subscript, and second is the column index or column subscript. So you can say that two-dimensional array can be seen as a table with x rows and y columns where the row number ranges from 0 to x minus 1 and column subscript ranges from 0 to y minus 1. You can see here in this figure, suppose a matrix having 3 rows and 4 columns. So you can see here 3 rows and 4 columns. Row index start from 0, 0, 1, 2 and column index start from 0, 1, 2, 3 like this. So matrix has 12 elements, 3 into 4. So 3 into 4, 12. So 12 elements can be stored in this matrix, where matrix 0, 0 is the first element and matrix 2 by 3 is the last element in the last row and last column. Let us see C program on two-dimensional arrays. Here in this program, we want to accept two-dimensional array and display the same. So first include the header file, hash include stdio.h, then include the conio.io.h, console.io.h for clear screen. In the main function, declare array int array of 3 by 3, then I and j index for row and column. For I equal to 0, I less than 3, I plus plus. For j equal to 0, j less than 3, j plus plus. So here I loop controls the number of rows and j loop controls the number of columns. So printf %d, printf enter, I am printing a of 0, 0, 0, a of 1, 1. So a in square bracket %d, I comma j. Scanf the %d array of ij. Read the a of 0, 0, a of 0, 1, a of 0, 2 like that. Now print the same matrix using the for loop. So here again for I equal to 0, I less than 3, then printf \n. You can avoid this printf \n by giving the command. Or you can give after the j loop this printf \n. So here for j equal to 0, j less than 3, j plus plus, printf %d \t array of ij. After the j loop, every row we want on new line, so give \n, printf \n, and close the I loop, then get it and return 0. Now run this program. First compile the program and then run. So first suppose 1, 2, 3 and 1 of 0, so 4, 5, 6. We want to accept 3 by 3, 7, then 8 and 9. It will display the array like in matrix format or tabular format. So we can use two for loops to accept the row and columns. Let us see another program to find transpose of an array. First include the header file stdio.h, then include the file hash include conio.h for clear screen function, Then in the main function, declare the array A having 10 rows 10 column to store the transpose. Again, same matrix 10 by 10. Then define row, how many rows you want, how many columns you want, and then ij for the rows and column index. Then clear screen. First you accept how many rows and how many columns you want to store. So scanf %d, %r, %c. Then accept the matrix using for loop. So for I equal to 0, I less than r, I plus plus. Again for j equal to 0, j less than c, j plus plus. Then enter the elements in like a of 0 0 format, a of 0 0, a of 0 1, a of 0 2, like that. Then read the elements using scanf %d, a of ij. Then after that print the same matrix using for loop. So here you can see again for I equal to 0, I less than r, I plus plus. For j equal to 0, j less than c, j plus plus. Printed %d, a of ij. After the j loop, you can give \n for starting every matrix row on new line. After that, we want to compute transpose. In transpose, row becomes column and column becomes row. So for I equal to 0, I less than r, I plus plus. J equal to 0, j less than c, j plus plus. Now in a loop, you can store transpose of j of I. A subscript is j of I. So we want row should become column and column should become row. So j of I equal to a of ij. So if the element is 1 of 0, it will store in 0 of 1 in transpose matrix. Then we want to print the matrix. So printf transpose of matrix equal to, for I equal to 0. Now here I is less than c and I plus plus. Then for j equal to 0, j less than r, j plus plus. So we want in transpose format. So row becomes column and column becomes row. So printf %d transpose of I, comma j. After that printf \n. Now run this program. Compile the program. Suppose we want 2 rows and 3 columns. So enter element 1, 2, 3, then second row 4, 5 and 6. So original matrix is here 1, 2, 3 and transpose of the matrix you can see. So 1, 2, 3 row becomes column, first column 1, 2, 3. And second row 4, 5, 6 becomes second column 4, 5, 6. Now again run the program. Suppose 2 rows and 1 column, simple. So transfer 2 rows here it becomes what, 1 column. 1 column becomes here 1 row. So 10 and 20. Like this we can use 2 for loops to accept the 2-dimension array and display the same. Our next topic is memory representation of the 2-dimension array. We know that in 2-dimension arrays, data is stored in tabular format, that is a row in terms of rows and columns. But it is a logical view or conceptual view to store data. But memory is physical memory is what sequential or linear format. It is what collection of sequential addresses. So how to store this 2D array in the memory? There are two ways. First is a row measure representation and second is a column measure representation. Now in the first method, row measure representation, elements are stored row wise. It is a row by row, row 0, row 1, row 2, like that. You can see in this figure there are 3 rows. So 1, 2, 3 is first row, row 0 is first row, then row 1, 4, 5, 6 and then second row. Now in column measure representation, elements are stored column wise. It is column 0 first, then column 1, then column 2. You can see here 147 is the first column stored in a physical memory first. In column 1, 258, here 258, and in column 2, 369, here 369. Now, how to calculate the address of two-dimensional array elements? For example, if M having R rows and C column is a two-dimensional array, so in the row measure representation, we can calculate the address like this. Address of any element, address of M of ij suppose, equal to base address. Here array name itself gives what? Base address. So here base address plus I, subscript I first, into number of columns C plus J subscript into element size. The size of element data type. You can say int type, float type, size of int, size of float, like that. In column measure representation, address of m of ij equal to base address into that first j subscript into number of rows plus I subscript into element size. For example, if you are given four rows and 3 columns, and address starts from 1000. So in row measure, m of 2 by 1 will be first base address 1000, then 2 subscript 2 into number of columns 3 plus 1, here j, and into 2. int bytes required, suppose 2 here, 2 bytes, so into 2. It will give 1014. And in column measure, same address will be 1000 plus 1 into 4. So 1 is j subscript here, and number of rows are 4 plus 2 into multiply by 2. So it will give 1012. Let us see assignment. Short question. Define two-dimension array. How to declare three-dimension array. In long question, explain the 2D array declaration and initialization with example. Then how 2D arrays are stored in the physical memory. Explain with example. I hope you will understand multi-dimensional array concept. If you like this video, please share and subscribe the college YouTube channel. Thank you for watching.